Can you solve this geometry where a circle is inscribed inside a triangle such that the outer part of this circle, which we call the circumference, is touching the triangle at this point, also at this point? From here to here is 20, from here to here is given as S, and from here, which is the radius, is said to be 6. We are now asked to find S. Now, whenever you have this type of mathematical problem, your ability to identify some circle theorems or circle properties is your only solution to solve this question. But don't worry yourself, I am going to help you to discover some of these theorems. So let's do it together. So each time you have a circle drawn and there is a line that touches the circle at a point and moves away, this is what we call or known as tangent. And whenever you hear about tangent, it reminds you about the theorem attached to tangent. Now let's go back to this our question. You can see that's the circle inscribed inside this right angle triangle, that the outer part of this circle at this point and also at this point, which forms a tangent with this right angle triangle. Therefore, it means that this line, and this line becomes the tangent to this circle. It forms a tangent. So what other things do we have to know? If you notice, we have a radius here. That's a point at the middle of this circle that draws a line down to the circumference of this circle. So any line from the center of a circle that touches the circumference of the circle is known as the radius. And remember that anytime the radius comes in contact with a tangent, it always makes an angle 90 degrees. It is known as tangent and radius theorem. Now, of what use will it be to us? Just like as you have seen, this is your radius which comes in contact with the tangent that makes angle 90 degrees here. We can also form as many radius as possible, such that from here we can form another radius to touch this line. That's from here. So, and from here to here also is 6 because it is another radius and all radius are equal. It means here to here, which is 6, here to here is also 6. If here to here is 6, that means here to here is also 6. If you notice, there is also a tangent that formed here because this circle is touching the lines of this right angle triangle at this point, making them to form a tangent. And this radius is also touching the tangent, which also make an angle 90 degrees here. Therefore, you notice that if from here to here is 6, that means from here to here should also be 6. And if you notice, this has formed a square. And as you remember, all sides of a square are equal. So here is 6, here is also 6, here is also 6, and this side is also 6. So if you look at our question, remember from here to here, that's the length from here to here is 20. Now, we've also deduced that since from here to here is 6, that means we need to find what will be from here to here because it can no longer be 20. That means we need to get the centimeter of this remaining length. And since the total length of this is already 20, that means we take away 6 from 20 and it will give us 14. Remember that the total length of this is still 20, just as we are given in our question. Now, what did we need again? If we observe also that from here to here is your radius, that's from here to here can also be another radius. That's from here to here. And at this point, this is also a tangent line. And if you look, you will notice that this line touches the circle at the tangent line. So we have it as tangent here too. At this point, also we have another tangent here. And this reminds you that each time you have two tangents coming together at a point, we say that the two tangents are equal. And this is a tangent. So this meets at this point, and this is a tangent that also meets at this point. So if we bring it out, we have something like this. So these are tangents, just like here. The tangent meets this one at this point and also meets this at this point. So each time we have two tangents coming together at a point, we say that two tangents are equal. And our reason for that is the tangent and tangent theorem. Now with this theorem, what do? It means from here to this end and from here to this end, they will be equal to each other. In that case, since here is 14, here will be automatically 14 according to the tangent-tangent theorem. Therefore, since from here to here is 14, that means from here to here will now be s minus 14. Because when we add the total length, we'll be able to get back the value of our x. So what do we need again? You will also see that this is in tangent with this, and also this other side is in tangent with this. That's the radius. So it means that from here to here and from here to here will be equal to each other because of the tangent theorem. I said that each time you have two tangents coming together at a point, that the two tangents are equal to each other. Therefore, since this is s, subtract 14, therefore this other side is tangent will be equal to s subtract 14, thereby obeying the theorem of tangent. So the total length here will now be 6 plus s subtract 14. If we add, we have our answer to be s subtract 8. Now, if we bring out this shape out, we are going to have our right angle triangle with the values we've already gotten here. We have 20 here, we have s subtract 8, and we're still looking for the value of our s. So we brought it out here. Now let's find the value of s. But since this is a right angle triangle and we are dealing with the size of a right angle triangle, we always remember Pythagoras Theorem. At this point, if you are a returning viewer, you are highly welcome. If you are a newcomer, kindly subscribe and remember to give us a thumbs up. Drop your thoughts in the comment section and share with your friends. So, applying the Pythagoras theorem, remember that Pythagoras theorem says that a square plus b square gives us c square, or is equals to c square. So, if we apply this Pythagoras theorem here, we have this to be our a, and this b, and this c. So, applying the Pythagoras theorem, we have it to be 20 squared plus s minus 8 all squared to be equals to, our c here is s, is equals to s squared, which is equals to 20 squared here is 400 plus, for this, just remember our algebraic identity that says for every a subtract b squared is equals to a squared subtract 2ab plus b squared. So if we apply this algebraic identity in our question, we now have our answer to be 400 plus, our a here is s, that's s squared subtract 2a, that's 2 multiply s multiply our b here is 8 multiply 8, which adds to our b here is 8, that's 8 squared, which is equals to s squared. So at this point, we applied the algebraic identity in order to solve this s subtract 8 all squared. So if we solve, we now have 400 plus s squared, we subtract 2 multiply s multiply 8 gives us 16s plus 8 squared is 64, which is equals to s squared. The next thing is to subtract s from both sides of the equation. Because they are positive, we subtract. So if we subtract s squared here and if we subtract it here, this will cancel out. Likewise this. We will now have 400 subtract 16s plus 64, which is equals to 0. The next thing is to collect like terms or add the like terms, and the like terms here is 464. So we now have 400 adds to 64 will give us 464. We subtract 16s to be equals to 0. So for us to get the value of our s, we add 16s to both sides of the equation, and when we do that, we have plus 16s plus 16s. If we solve this, we cancel out 464 to be equals to, when 0 adds to 16s, we have 16s. So the next thing is to divide both sides by 16, and if we divide, we have it to be 464 divided by 16 and 16s divided by 16. This we cancel out. Our s will now be 464 divided by 16. If we divide, it will be equals to 29. Therefore, our s is equals to 29. Thank you for watching, and don't forget to subscribe. Click the notification button so that you'll be able to see other of our amazing videos. Comment and like and share your thoughts in the comment section.